Hello, today we are going to start a new chapter, that is Principle of Mathematical Induction. We will first discuss about the important points regarding it. First of all, what do you mean by a statement? Statement is a sentence or description, looking at which you can say whether it is true or false. Such a sentence or description, we can call it as statement. For example, if I say 2 divides 6, that is a statement. And this statement is quite true. I can say it is true because I know that 2 divides 6. And it is something dealing with maths. So it is called mathematical statement, not an English statement, mathematical statement. Suppose if I say Delhi is capital of India. Of course, it is a statement because I'm describing something and I'm giving you a sentence. And it is true also. But it is not mathematical statement. It is English statement. Let us take one more example. Suppose if I say there are 7 days in a week. It is a sentence and this is quite true. But this is not mathematical statement. It is again English statement. Coming to the fourth example. X plus 1 is factor of x square minus 3x plus 2. Actually, if you take x square minus 3x plus 2, it is factorized as x minus 2 into x minus 1. So x plus 1 is not the factor. This is a statement, but it is not a true statement. It is a false statement. Of course, it is a mathematical statement which is not true. It is false. In the same way, suppose if I say A union B complement is A complement union B complement. I know it is mathematical statement because it comes in maths in the lesson 6. But the thing is, this statement is false because the actual formula is A union B complement is A complement intersection B complement. So now that we know what are statements, we will come to mathematical statement because this class is as such maths class, not an English class. So what is mathematical statement? A statement which involves mathematical relations, all the relations, all the things which are concerned with maths, which deal with maths, they are called mathematical statements. The mathematical statements are denoted by P of n, where n belongs to set of natural numbers. So when we are talking about statements, we are dealing only with natural numbers, no integers, not whole numbers, only natural numbers we are dealing with. For example, I will give you P of n, a mathematical statement as 6n plus 5 is a prime. This is how I'm telling in short. Now suppose if I want to know what is P of 2, I will put n as 2. 6 into 2 plus 5. That is 12 plus 5. That is 17. And we know 17 is a prime. 17 is a prime. So this statement is true. I mean, P of 2 is true. Suppose if I want to check P of 3, what I will do, in place of n, I will put 3. 6 into 3 plus 5. That is 18 plus 5. That is 23. I know 23 is also a prime. That means the statement P of 3 is also true. I can see. Now I will see P of 4. What is P of 4? I will put n as 4. 6 into 4 plus 5. That is 24 plus 5. 29 is also a prime. I know it. That means I can say P of 4 is also true. Next, I will put n as 5. 6 into 5 plus 5. That is 30 plus 5. But 35 is not a prime. That means P of 5 statement is false. It is not true. So I can say which statement is true, which statement is false in this way. Let us take one more example. For example, I will take P of n. P of n is a statement like n cube plus n is divisible by 3. So first I will put n as 1. 1 cube plus 1. 1 plus 1, 2. 2 is not divisible by 3. That means P of 1 is false. Next, I will take P of 2. 2 cube plus 2. 8 plus 2, that is 10. 10 is also not divisible by 3. So P of 2 is also false. Coming to P of 3. 3 cube plus 3. That is 27 plus 3, 30. Yes, 30 is divisible by 3. So I can say P of 3 statement is only true here. Again, if I see P of 4. 4 cube plus 4. 4 cube plus 4 is 68. 68 is not divisible by 3. So I can say P of 4 is false. Let us take one more example. Now I will give P of n a statement that 3 power n is greater than n. Now what you have to tell is, if P of n is true, then P of n plus 1 is also true. So first what I will take is, let P of n be true. That means 3 power n is greater than n. This is true. Now if I take P of n plus 1, that means 3 power n plus 1. If I take, I have to show that to prove my work is to prove. What I have to prove? 3 power n plus 1 is greater than n plus 1. This is my work. So remember, what is my work? I have to prove this. So what I will do? I will start with 3 power n plus 1. I will write it as 3 power n into 3 power 1. Because 3 power n is greater than n, this 3 power n is greater than n, and apart from that I have times 3 into 3. So that means this is 3n. And I know 3n is nothing but n plus 2n. And of course, 2n is, whatever be the number, 2n will be greater than 1. I'm very much sure. Because n is a natural number. Like if I take n as 1, 2 into 1 is greater than 1. 2 into 2 is greater than 1. 2 into 3 is greater than 1. So I know 2n is greater than 1. So I will write this will be greater than n plus, instead of 2n, I will write 1. 2n is greater than 1. So what I got? I started with 3 power n plus 1 and I got greater than 1, which I have proved it. This I have proved. So I have proved that if Pn is true, I have used this. Where did I use it? I used it here. 3 power n is greater than n. I used it and I have shown that P of n plus 1 is true. We will take one more such example. I will give you a statement P of n. That is 2 power 3n minus 1 is an integral multiple of 7. What I have to do here? I have to show that if P of R is true, then P of R plus 1 is also true. That is what I have to prove. So what will I start with? Let P of R be true. That means I'm taking 2 power 3n minus 1 is multiple of 7. That means I will take 2 power 3n minus 1 is 7 into m. Multiple of 7 means 7 into m. 7 times m. So this is true. Now what I have to prove? I have to prove that P of R plus 1 is true. That means 2 power 3 into n plus 1 minus 1 is multiple of 7. This I have to prove. This work is my work. So I will start proving. How will I prove? I will start with 2 power 3 into n plus 1 minus 1. I will show that I can take n plus 1 or r. Suppose if r is there, you take 2 power 3r minus 1. 2 power 3r minus 1. R plus 1 means 2 power r plus 1. N or r, it is one and the same. So I will start with 2 power 3 into r plus 1 minus 1. So how will I write it? I will write 2 power 3r plus 3 multiplying minus 1. How will I write this? 2 power 3r into 2 power 3 minus 1. Now I will use the above PR. I have taken let PR by true. So I will use this 2 power 3R. How can I write? From this I can write 2 power 3R equal to 7M plus 1. So I will write 2 power 3R as 7M plus 1 into 8 minus 1. So I will write 7M into 8 plus 8 minus 1. Or I will write 7M into 8 plus 7. Or I will take 7 out. So 8M plus 1. Instead of 8M plus 1, I will write K, 7K. So I started with this and I got this. What did I start with? I started with 2 power 3 into R plus 1 minus 1 and I got it as 7K, multiple of 7. So I have proved that P of R plus 1 is true. This is what I have to prove. So what I have given you now, all these examples, they are taking a statement and saying, taking a mathematical statement P of n and saying it is true or false. So what happens is, suppose I give you a mathematical statement. I am stressing on mathematical statement. If you want to discuss about this mathematical statement, if you have to give a reasoning, if you have to discuss about the scientific idea, if you want to discuss about conclusion, that you can do in two ways. One is method of deduction and the other is the method of induction. What is deduction? Deduction means giving reasoning. If I give you reasoning, that is deduction. And what is induction? I will take a particular thing and I will say it is true. And then I will proceed to a general thing and I will say general thing is also true. That is called induction method. So what is actually induction method which we are going to do now? That is only the name of this chapter. Principle of mathematical induction. What is this principle of mathematical induction? It will help us to prove whether a statement is true or not. If it is true, for what values of n it is true? For what values of n it is not true? So this principle will help us in that. So suppose if I give you a mathematical statement, how will I proceed with that mathematical induction? Principle of mathematical induction. Always my first step is, in the statement, I will put n equal to 1. Always, always, for every question. And I will see with my eyes whether this statement is true or not. Suppose I will get P of 1 is true. Now, what will be my next step? I will think for n equal to k. I will just close my eyes blindly. I will say P of k is a statement which is true. I will not say anything. Just I will say put n equal to k. It will be true. I'm not proving. In the first statement, I'm proving. I'm putting n equal to 1. I'm seeing with my eyes open and I'm saying it is true. But for n equal to k, I'm closing my eyes and I'm saying P of k is always true. After that, my third work is I will use this P of k somewhere or the other, somehow or the other, and I will prove. I will prove here. I will not sit simply now. I will do lot of work. I will prove that for n equal to k plus 1, P of k plus 1 is true. When I do all these three works, I can generalize. I will say by till now I was giving particular cases. Now I will generalize and say by principle of mathematical induction, the statement P of n is true for all natural numbers. That will be my final statement. Actually, what is the meaning behind it? I will tell you. First, what I'm doing, P of n is a statement. First, what did I do? I put n equal to 1. I will see with my eyes open and I will see that P of 1 is true. Once I got P of 1 true, I will close my eyes and say, if you put n equal to k, let P of k be true always, no doubt. And then using P of k, I am proving for n equal to k plus 1, proving P of k plus 1 is true. And so I am saying for all n natural numbers, P of n is true. What is the principle lying behind it? I will explain to you. I have proved P of 1 is true. That means I will compare P of k to P of 1. So P of 1 is true. I got it. Then I have proved P of k plus 1 is true. That means P of 1 plus 1, P of 2 is true. Using P of 1, I can prove P of 2 is true. This process will continue. Now, because I have proved P of 2 is true, using P of 2, I can prove P of 2 plus 1, that is P of 3 is true. Now I have proved that P of 3 is true. Using P of 3, I can prove P of 4 is true. Using P of 4, I can prove P of 5 is true. P of 6 is true. P of 7 is true. Like that, P of n is true for all natural numbers. This is actually the principle of mathematical induction lying behind. But this method you will use only in PU. Whereas in K-set, we have shortcut methods. We will use shortcut methods only. First, I will show you the PU method. I will take one question. First, P of n is a statement n square plus n is an even natural number for all n belonging to set of natural numbers. This is the statement. So in PU, what did you do? I will do according to that. First, what I will do? I'll put n equal to 1. So P of 1. 1 square plus 1. That is 2. Yes, I got 2 is an even natural number. That means I am keeping my eyes open and I'm saying P of 1 is true. After that, what is my second work? For n equal to k, I'll close my eyes and I will say let P of k be true. That means P of k, what is it? K square plus k. It is an. It is. I'm not proving anything. I'm saying it is. It has to be even natural number. That means k square plus k. It is even number. Even number means multiple of 2. 2m. So this I am showing blindly. But this I will use later. When? Now I will use. Now I will put n equal to k plus 1. And I will start with P of k plus 1. I will prove that it is true. I will prove that P of k plus 1 is an even natural number. How will I prove? I will start with P of k plus 1. What is P of k plus 1? It is k plus 1 whole square plus k plus 1. If you want, you can see back. P of k plus 1 is k plus 1 whole square plus k plus 1. Everywhere you are putting n as k plus 1. So now I have to show that it is even natural number. So I will write this as k square plus 2k plus 1 plus k plus 1. Out of this, I will pick up k square plus k. I will group it separately and the remaining 2k plus 2. Why did I take k square plus k? See the previous page. I said we have to use this. K square plus k is 2m. So I will write k square plus k is 2m. I'm using plus 2k plus 2. So I will take 2 common, m plus k plus 1. So 2 into this I will write some letter m. So what did I get? P of k plus 1 is multiple of 2. That means it is an even natural number. So I have proved P of k plus 1 is true. So after proving P of k plus 1 is true, now I can say by principle of mathematical induction, P of n is true for all n belonging to set of natural numbers. So this is the method you have learnt in PU. I will give you one more example here. Let P of n be a statement 1 plus 2 plus 3 plus up to n. It is n into n plus 1 by 2 for all n belonging to set of natural numbers. So I have to take this statement. First work, I will put n equal to 1. That means P of 1. P of 1 means what? Starting with 1, ending with 1 because n is 1. So only 1 I have. Equal to, I will put n as 1, n as 1. 1 into 1 plus 1 by 2. So what did I get? 1 equal to 2 by 2. 1 equal to 1. I am putting everywhere n equal to 1 in this statement. And I got the correct answer 1 equal to 1. So clearly opening my eyes, I will see and tell P of 1 is true. Now after P of 1 is true, I'll close my eyes. For n equal to k, let P of k be true. P of k is true means what? I can write P of k statement 1 plus 2 plus 3 up to k. I'm putting n as k equal to k into k plus 1 by 2. In the statement given in the question, I'm putting that. But remember, this is very important. Even though I'm closing my eyes and writing, this is very important, which I'm going to use in future when I'm doing the third work. In the third work, I will put n as k plus 1 and I will prove that P of k plus 1 is true. How will I prove? I will start with P of k plus 1. That means I will take 1 plus 2 plus 3 plus up to k plus 1 I will take. But before k plus 1, I will have k. That I have to remember. So now I told you in the previous page, for 1 plus 2 plus 3 up to k, I will write k into k plus 1 by 2. I'm going to use it. I said before k plus 1, there will be k. So 1 plus 2 plus 3 up to k, I can use k into k plus 1 by 2 plus k plus 1. Now what I will do, I will take k plus 1 common. What will I have? K by 2 plus 1 because I have taken k plus 1 common. That means I have k plus 1 into k plus 2 by 2. So this P of k plus 1, I can write it as k plus 1 into k plus 1 plus 1. Instead of writing k plus 2, I'm writing k plus 1 plus 1 by 2. Why I'm writing like this? Because concentrate on k plus 1. Concentrate on k plus 1. K plus 1. And then what you can see. How is it looking like? It's looking like something which we know. P of n equal to n into n plus 1 by 2. P of n statement. This is n. K plus 1 is n. K plus 1 is n. K plus 1 is n. That means I got the Pn statement only. See, what is the Pn statement? N into n plus 1 by 2. Instead of n, k plus 1. Instead of n, k plus 1. So P of k plus 1 is true. From this, I can say P of k plus 1 is true. So I can say by principle of mathematical induction, P of n is true for all n belonging to set of natural numbers. Okay. Now you have to remember some important things which will be useful for us in the chapter. Suppose, first one, there is arithmetic progression. What is arithmetic progression? Just I will tell you a little about that. First term will be A. To that you will add D, A plus D. Again add D, A plus 2D. Again plus D, A plus 3D. Like that the terms will be. So in arithmetic progression, this is P1, first term. This is second term. This is third term. This is fourth term. Like that. If you want to find nth term, the formula will be A plus n minus 1 into D. A, I told you, A is the first term. A is the first term. What is D? D is something which you are going on adding. So D is called difference between two consecutive terms. Like, what is D? If you do T2 minus T1, you will get D. Or if you do T3 minus T2, you will get D. Or if you do T4 minus T3, you will get D. That is D. And what is N? N is number of terms. How many terms are there in arithmetic progression? So this is all I want to tell about arithmetic progression, not much. Second is I will give you some information about geometric progression also. What is geometric progression? First, I will start with number A. I will multiply R to it, AR. Again into R, so R square. Into R, R cube. Into R, AR power 4. Like that it will continue. So this is called T1 first term, second term, third term, fourth term, fifth term. Like that it will continue. If you want to find nth term, the formula is A into R power n minus 1. Again, what is A? A is the first term. You can see A is the first term. What is R? R is ratio of consecutive terms. That means R you will get by taking T2 by T1 or T3 by T2 or T4 by T3, like that. What is N? N is number of terms present here. So this is what about geometric progression. Then I want to tell you some formulas. The sum of first n natural numbers formula is n into n plus 1 by 2. The sum of squares of first n natural numbers is n into n plus 1 into 2n plus 1 by 6. The sum of cube of first n natural numbers is n square into n plus 1 whole square by 4. So these formulas are very, very important later on. Now suppose when we do some problems, we have to use shortcut methods. I will show you one or two shortcut methods also. Let us see these shortcut methods. Suppose if I ask you, I'll give you a statement P of n. It is 2 into 4 power 2n plus 1 plus 3 power 2n plus 1. I will ask you, it is divisible by which number? Some number. So what I have to do? First, I will put n equal to 1. I will find what is P of 1. 2 into 4 power 3 plus 3 power 3. So what I will have? 2 into 64 plus 27. 128 plus 27. Right? I'm putting just n equal to 1 everywhere. So what I will get when I add 5, 5 and 1? This is the answer I am getting. Isn't it? Okay. Now I will put n equal to 2. P of 2. What I will get? 2 into 4 power 5 plus 3 into or 3 power 5. So I will have 2 into what is 4 power 5? 4 power 3 is 4 into 4 into 4. 16 into 4. 64. 4 power 5 means I have to multiply 4 again. 4 power 4. Multiply 4. So 16, 256. Multiply 4 again. 24, 2, 1024. So I will have 1024 plus what is 3 power 5? 243. So I will have 8402 plus 243. So when I add 11 and then 8 plus 1 is 9, then 2 and then 2. So after seeing these two numbers, I have to find HCF, highest common factor. I have to see highest common factor of 155 and 2291. Then I will get the required answer. So this is one procedure which we will follow in the problems. Sometimes we will use another procedure also. Like we will prove for n equal to 1, n equal to 2, n equal to 3, n equal to 4, up to 4 we will see and prove it. That's all. The third procedure is in some problems, if there are n consecutive, one second, I will erase this. Suppose if I have n consecutive integers and I am finding product, that means 1 into 2 into 3, like that I'm finding product. This will be divisible by n factorial, because this is nothing but n factorial, and n factorial will be divisible by n factorial because you will get 1 as the answer. Similarly, if you take product of r consecutive integers, that means if you take 1 into 2 into 3 up to r, it will be divisible by r factorial for sure. If you take product of 3 consecutive integers, it will be divisible by 3 factorial, that means 6. For example, if I take n plus 1, n plus 2, I can say, because these are 3 consecutive integers and we are finding the product, it is divisible by 6, 3 factorial. I can say, if I take n minus 1, n minus 2, this is also product of 3 consecutive integers. So this is also divisible by 3 factorial, that is 6. So these all are shortcut methods. While proving in some of the questions, not all, while proving some questions, I can use this. So let me do some problems from MCQs. Today, we may not be able to do many, but we will do at least a few. The first question, n into n square minus 1 is divisible by which number? Options are 24, 36, 15, 18. So what I will do, I will take the statement. I'll start answering. So I will use a different color. So I will take the statement P of n into n square minus 1. I will put n as 1. What I will get? 1 into 1 square minus 1. That is 0. Next, I will do P of 2. 2 into 2 squared minus 1. So I am getting 6. Next, I will take P of 3. What I will get? 3 into 3 square minus 1. So I am getting 24. Now what I will see is, I will see highest common factor of these two. How to find HCF? Do you remember? How did you find HCF? So 6 is there. What are the factors of 6? 1 into 2 into 3. What are the factors of 24? 1 into 24 means 3 into 8. You can take like this, 24. 2 12s, 2 6, 2 3s, 3 1s. So 1 into 2 into 2 into 2 into 3. So highest common factor means what? What all are there I will take. There are 3 2s. I will take 3 2s. There is 1 3. I will take 1 3. So already I have taken 2 here. 1 2. A single 2 I have taken. A single 3 I have taken. I need not take again. So 24 is the highest common factor. This is one method of doing highest common factor. What is the other method of doing highest common factor? I will take bigger number 24 and I'll divide by 6. So 6 fours 24. 0. I'm getting 0. So 24 is the HCF. Or if you feel difficulty in finding HCF, there is one more method also. You can go for P of 3 also. Instead of doing all these, not LCM, we are doing HCF. HCF is a little bit difficult. So I can go for P of 4 also if you want. So what is P of 4? 4 into 4 square, 16 minus 1. So 4 into 15, that is 60. So if I go on taking like this, which one will be true? I have to see. So all these are divisible by which number? I have taken n equal to 1, 2, 3, 4. 1 square, 2 square, 3 square, 4 square. Isn't it? So I can say which number will divide all these. Which number will divide all these means I can't see like 0, 6, 24 and decide. I have to take more numbers. Like if I take P of 5 also, 5 into 5 square, 25 minus 1. So 5 into 24. What is 5 into 24? It is divisible by 24. So I can select 24 as my answer. 24 is the one which I can say n into n square minus 1 is divisible by 24. Next, coming to the second question. One more question we will take. Like, I will give you a statement P of 1. 11 power n plus 2 plus 12 power 2n plus 1 is divisible by which number? You have to see. In the options, I will give you 132. I will give you 133. I will give you 25. I will give you 131. So how to prove this? Let me start proving. First, take P of n equal to 11 power n plus 2 plus 12 power 2n plus 1. Now slowly I will start putting numbers. First I will take P of 1. That means I have 11 power 3 plus 12 power, because I'm putting n as 1, 12 power 3. So when I do this, 11 power 3, 1331. 12 power 3, 1728. This is 3059. Clearly, 3059 is 133 into 23. That means it has to be divisible by 133. I can select option B. Okay, let us go for one more question before completing this class. I will give you a statement P of n. P of n is n power 5 by 5 plus n cube by 3 plus 7n by 15. You have to say it is a first option positive integer. Second option positive odd integer. Third option positive even integer. Fourth option prime integer. So I will start proving this. First, what I will do, I will take P of n power 5 by 5 plus n cube by 3 plus 7n by 15. I will put n as 1. So what I will get? 1 by 5, 1 by 3 plus 7 by 15. I will take common denominator 15. 5 3s, 3 5s, and then 7. I am getting 15 by 15, which is 1. 1 is neither prime nor composite number. So obviously prime integer, because 1 is not a prime. I can cancel that. Next, P of 2. What is P of 2? 2 power 5 by 5 plus 2 cube by 3 plus 7 into 2, 14 by 15. I will take common denominator here also. When I take common denominator, 32 into 3, 2 power 5 is 32, into 3, 96. 2 cube is 8 into 5, 40 plus 40. So I am getting 150 by 15. It is 10. Clearly it is even integer. It is not odd. So odd I can cancel, not odd. Okay, next. Because there is no place, I will write P of n again here, again and again. We can't go back and refer. What is P of n? N power 5 by 5 plus n cube by 3 plus 7n by 15. So what I have seen, I have cancelled of the options. I have cancelled odd integer and prime integer. So I am left with even integer and positive integer. Of course, 1 is not even. Clearly 1 is not even. So I can cancel even also. Left is positive integer. So A is the correct answer. Pn answer. The answer for this statement will be just a positive integer. Not odd integer, not even integer, not prime integer. So in the next class, you come more prepared with mathematical induction chapter lesson. We will do more problems, but we will do the last class for mathematical induction in the next class. Only 2 classes. So be prepared well. With this, we will end the session.